Okay, we will continue for piecewise function. So for the previous class, we already done for egg function. Piecewise function is a function that will define different expression of different part of its domain is called piecewise function. Means that you can see for this function, so we will read x more than 0, it is a function of linear x, but for x less than 0, it is a negative x. So this is what we call is piecewise function, means our function is not in a whole piece. They will separate by piece. For x more than negative 2, it will x minus 1. For x less than negative 2, negative x minus 5. Okay, so this one we call it piecewise, means piece by piece, part by part. They will join together, become a whole function, become a piecewise function. For example 5, how to sketch a piecewise function. First, draw our xy axis, means that this one x more than negative 2, x more than negative 2, for this right hand side, we are drawing this linear x minus 1. Then for x less than negative 2, for x less than negative 2, for this left hand side part, we were drawing for negative x minus 5. So for this part, x, when x equals to, so this is my starting point. When x equals to negative 2, my y equals to negative 2, negative 1, so it will become negative 3. Okay, so therefore, my starting point here will be include, so it will full circle negative 3. So I want to draw this x minus 1 is a linear positive gradient. Positive gradient will be going up. And then y-intercept is at negative 1. So this is my first piece, where my first piece of the graph is a linear graph for the domain negative 2 onwards to infinity. Second part, we are going to draw for negative x, negative 5, for x less than negative 2. So I want to find the point first. The point for x equals to negative 2. For second function here, it will equals to 2 minus 5. Piecewise function here, piece by piece is joining at the same point. Alright, so this line is a negative gradient, so it will going down. So when you're going down, they will make an intersection at x-axis. So x-intercept, you will let y equals to 0. So negative x minus 5 equals to 0. So x will equal to negative 5. So they will intersect x-axis at negative 5. So this is my another piece of the function. So when I want to label, this is my negative x minus 5. And then this is my another function, which is x minus 1. So piecewise function, piece by piece. So this is one piece, this is another piece. So this is coincident. This graph is joining at negative 2. So sometimes they won't join, so they will draw a separate point. So this is how we sketch a piecewise function, part by part, followed by the domain they give us. Next, we are going to learn how to write our absolute function in piecewise form. So this is an example of absolute function that we write in piecewise forms. The idea will be fx equals to modulo something. So when I want to write it in piecewise, so that something greater than 0 is defined as positive. So it will be positive for the function. So that something will be, so this one got equal. So this part, when it less than 0, so this function will be negative for that function. So for this function less than negative, we will times a negative. So for the function greater than equals 0, we will times a positive. So this is how we write a modulus, or how we write an absolute function to become a piecewise function. So for example here, it is x. So for x more than equals 0, so it will positive x. So for another piece will be x less than 0, so it will times a negative, so it becomes negative x.